Good morning, Year 11s. How's it going? I'm sorry I'm a couple of minutes late. Just been trying to get myself all up and running. Been drinking all the coffee in the world. Cheers, Monday morning. By the way, whoa, no, I've got, let's get rid of that. I've got my second laptop running in order for me to be able to do the register and see the chat. Yeah, it's going well. I've got Harry, I've got Ira. It's good to see you guys. Oh, I've got Hibber, I've got MJ. Oh, I love how MJ now tells me it's MJ every time. Oh, Ashy Potato. Whoop, 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 whoop. Got Minwee? Yes. Doing so well. Hey, Mavella. Morning, guys. Morning, everybody. Morning, Sian. Yay, got Sian. So, sir, you might just forget me. No. What? Hi, I'm MJ. Morning, everybody. By the way, guys, you 11s, I have to do a shout out. So I had a phone call from an old friend of mine, friends actually, who I worked with in the UK. And morning, Merrill. And they've been watching my YouTube channel, which is so embarrassing. Especially when I can't spell to save my life recently. I have no idea why all of a sudden it's just gone so haywire. But I mean, I've just been really struggling. And they've been watching my YouTube channel, which is so embarrassing. But I did say that I'd give them a shout out. So I've got to do a shout out to Dave and Louise. Hello. I doubt they're going to be watching live. This is like crazy early for them. Check out everyone arriving. I've got a Liz. I'm doing really well. Do I have Audrey? Did I see Audrey there? Hey, Merrill, it's not something new. You can't spell. You guys are so mean to me. You're so mean. Like, seriously mean. I've got Minwee. I've got Merrill. I've got Harry. I've got Aisha. I've got Hibber. I've got Sian. I've got Merrill. Yeah. I've got Isha. Good morning. I've got Marcellus. I've got Julian. Yo, Julian. I've got Marcellus. I highly doubt I've got that. Truth hurts. Oh, man. Lying is a sin. Oh, you guys are so... Oh, man. Oh, got Kefren. Got Marcellus. Woo. Got MJ. Got Kefren. Got Ira. Got Russell. I got Emmeline. Anyone seen Emmeline? Yeah. Got a Liz. Yep. I haven't seen Michael in forever. Has anyone seen Michael? Elijah. Oh, man. Anch is always here. Man. He's doing so well. Oh, well. He was here. There's Michael. Michael, it's good to see you, dude. Good morning. Amazing. Has anyone seen Emmeline? There you go. I know, right? Eh? Oh, funny. Right, so guys, do you know what? So I deliberately, at the end of last lesson, when we finished the worksheet, I deliberately didn't post another revision sheet. We've been told that we shouldn't be overloading you guys with work. Oh, Emmeline, so nice to see you. That we shouldn't be overloading you guys with work. So what I've done today is I'm going to go through a worksheet today, even though that you haven't had it. I'm just going to go through it as a series of questions. So you've had a lesson off from me. Yeah. So at the end of this one, I'll post another one. Then I'll skip one. So every other YouTube video, I'm going to send out a worksheet for you guys to have a go at. It just means that you're not getting them consistently. You know, we have 3 lessons a week. And I don't really want to be giving you guys homework every lesson. And so, as I said, that's kind of how I'm going to manage it. I'm also, just so you know, I'm also working on a method of trying to be able to give a bit more of assessment of you guys. Some kind of like online assessment form that you guys will have to fill in. Like, I'll have chemistry questions, which will be timed. I'm working on that. I haven't managed to find a website that does it appropriately quite yet, but I am working on it. to try and act as a bit more of an assessment. So if it's timed, it limits, you know, your ability to be able to look it up in notes. And so it kind of acts as a bit more of an official assessment. I mean, obviously it isn't. It's just a way of me being able to ascertain how you guys are getting on. Okay, so at this point, I think it's time I start my lesson. I'm still missing Tom, still missing Anch and Elijah. I'll mark them as not in for now, but I have everyone else. I'll do that. I will also keep it there as well. Okay, so let's share my screen. Let's share that. Click on that one. There we go. So now you guys can see my screen. And this is, so today's lesson, what I'm going to get you guys to do is, as we're going through it, you can pause the video, have a go at the questions that you want to have a go at. The ones that you're feeling a little bit less confident with, you can then have a, you know, you can just watch the way I talk, the way I go through it. I'm also going to try and throw in some extension bits when it comes in for the A-level bit as best I can. So the first thing I want you to do is we've got 8 questions where it's given you the word equation. And this is lower level. This is a Love 4. Yeah, Love 4 stroke 5. By the way, I shouldn't really do that because each individual one is slightly, so that each one has its own level. So I won't do that. I'll level each one as we go through. So can you pause the video? And I'd like you just to have a go at the first 4. In fact, no, change that, scratch that, 2. Have a go at the first 2. Now, the reason why I do that, it's nice to be able to have a go at the first 2 and then make those amendments so that when we go through it, you'll be able to see improvement. Yeah, and there is improvement in the latter half, not so much at the top one, but in the latter half, certainly. Okay, so once you've had a go at the first 2, you can unpause it. So copper plus oxygen, this is a nice, easy start to the lesson. Yeah, which is good. So we're going to form copper oxide. I'm pretty sure. Can I just say, by the way, that I actually don't like that. Chances are it's going to be copper 2 oxide. You should actually have to quote the Roman numeral for copper. It's a transition metal, and there does exist. Hey, Mr. Duncan, sorry I'm late. I've just woken up. Harry, is this paper on the classroom? No, it's not, Harry. I didn't really want to post it because I didn't want you guys to have a go at it. Just write down the answers for these on paper. I can put it on the classroom if you want. Do you want me to do that now? I can do. That's pretty easy for me to do. Classroom year 11. Right, okay, there we go. See, look, it's all kind of, I'm ready to go for the next one, you see. Let's see if I'm happy to put it on now that, yeah, I think that's very reasonable. I think this is revision 10. I think this is what this is. Rev 10 sheet, I'm pretty sure. Rev 10 sheet. There we go. I'll just do these. You can, I'll add them now and then add file. From computer, this is in my documents in the year 11 worksheets, Rev 10, there we go, and go. I'll also put on the answers after Anch as well. Harry, sorry. Damn, I got that wrong twice. Let's go back to, I'm going to do the register for, it's good to see you, Anch. I was really sad when you weren't here. I was like, oh, Anch isn't here. Thank you. Yes, please. Cool. So, assign, there you go, folks. So, revision 10 is on. So, just to mention the copper thing. So, we've got copper 2 oxide being produced. Just so you know, by the way, this is actually for GCSE and it's quite heavily asked. This is a lower level. This is a Love 3, Love 4. It's very lower level. But there are extensions that we can talk about here. Copper 2 oxide is black, and you have to know that the color of copper 2 oxide is black. There is also, just so you know, a copper 1 oxide, which is but you don't need to know its color. But copper 2 oxide, you must know, has a black color. It's black powder, black solid. Right, the next one, which I think is a really great one, is a combustion. It's actually easier to do this one. Hydrogen sulfide plus oxygen going into symbol here, folks. Yeah, so this is actually a combustion reaction. Now, some people would probably ask me how I know this. The reason being is this one here is a metal plus oxygen. This is a metal and oxygen. What that means is this is just going to be a standard oxidation. However, this one is a covalent. Yeah, as soon as you see covalent in oxygen, you're going to be going through a combustion kind of reaction rather than a standard kind of oxidation on a metal forming an ionic. So this one is much, much harder, much higher level. That's actually going to be probably a love 6, 7. That's hard, that. And so this one's actually going to form water and sulfur dioxide. Water and sulfur dioxide. Just to explain how I know that, if you ever have a reaction with sulfur, by the way, it's easier to do that equation. It's easier to understand when you see it in symbol form. Yeah, you can actually see what's going to happen better. The hydrogen, the oxygen and the sulfur kind of switch, yeah, and then you're forming SO2. Just so you know, sulfur is a tricky one because sulfur can exist as sulfur trioxide, but it has to be made very specially. SO2 is what it will make straight off the bat. If you don't have it under any particular conditions, you're going to form S2. Now, of course, because it's a word, we don't have to balance, which is always lovely. That's why that equation there would have gone up to a love 8 if it had been a symbol equation. But that's a clever one because of the sulfur. And that's the reason why it's so high in terms of its level. Most students would get that wrong. Right, so I know that you guys should have had a go at the first two. Can I ask a question, by the way, on the chat? Now, I realize that I'm asking you these questions and asking you to pause the video. Do you then watch it back at 2 times speed or something to catch up? I just don't know how you manage it. I wonder if you can. Just give me a bit of feedback. Right, the next two, have a go at the next 2 equations. And then unpause the video. Sometimes we just jump. Oh, okay. Right, okay. That's interesting. Right, potassium water. Again, by the way, love 6. It's higher level. And annoyingly, this one for me shouldn't be a love 6. I don't pause. Okay, you just kind of have a go when I'm doing it. Yeah. Now will I speed it up? Yeah. That's good to know. Thanks for that. This one is a love 6, but shouldn't be. It's really frustrating because this is a star. This one comes up at GCSE pretty much every year. There is always a group 1 with water somewhere, which is ridiculous. We're going to form potassium hydroxide and hydrogen. This is metal plus water. Plus hydrogen. Far more entertaining, by the way. If you drop that into symbol again, jumps way up. Most people will get the potassium hydroxide wrong. They'll forget to balance, very common. Next one, calcium carbonate. Oh, love this. Dropping it now. So all of these rules that we're running here, these are the equation rules, and these are such good practice. I've got A-level kids who still can't do these, folks. Because they just haven't practiced all the rules that go with it. So this is a metal carbonate. This is a metal carbonate reaction, which means with an acid, which means I'm going to get, by the way, it's actually M2CO3 because calcium's a 2. No, it's not. I tell a lie. I tell a lie. Calcium carbonate is just CaCO3 because it's a 2 plus and a 2 minus. Hydrochloric acid, HCl. And we're going to form calcium chloride. Calcium chloride, salt, water, and carbon dioxide. The acid reactions just need loads and loads of practice, folks. Loads of practice. And I'm putting carbon dioxide. Carbon dioxide. It's the carbon dioxide song. Very famous. Big hit in the 60s. Nickel oxide, that's not fair, just so you know, not fair. It's a transition metal and they haven't given you its oxidation state. What that means is you make an assumption it's 2 plus. Just to tell you, it's a really good rule, this. Unless, if they don't tell you the oxidation, I'll explain why. And this is actually a nota bene, by the way, for GCSE. So the transition metal block, I'm just going to go full screen snip on this one. There we go. The transition metal block, which is this bit, No, which is this bit here. In fact, you know what? I shouldn't do that. What I should actually do is I should do this. This here is the transition metal block. Yeah. All of these guys. Now, transition metals have got four. You learn so little about them, folks. So little. But the few facts you do know. Number one. I don't know if it's gonna let me zoom in. It's not gonna let me. No, definitely doesn't let me. One, they have variable oxidation states. Oxidation states. This means variable charges. The example there that you've got to know is Fe2 plus and Fe3 plus. They all have 2 electrons in their outer shell. Yeah, all have 2 electrons in outer energy level. Outer energy level. Just go straight over boron, carbon, and nitrogen there. Pah! Who needs them? Next one, they form colored compounds. Yeah, colored compounds. Last one is they're pretty much mostly all unreactive. They're unreactive. So those are the 4 things, and you don't need anything else, guys, apart from that. Now, the tricky one, of course, is the variable oxidation states. Yeah. And in this case, they should have always given you it. Nickel is part of the transition metal block. Nickel's there. Now, what that means is if nickel is there, then they should have to give us a Roman numeral. But they haven't in this case. What that means is we're going to make a big assumption that it's going to be a +2. The reason being is because they all have 2 electrons in their outer shell, they can all form a +2 ion. Yeah. There are some that actually don't have a stable +2. They're very rare, but there are. Scandium is one of them. Scandium is a bit of a nightmare. Scandium doesn't do a +2. It actually just does a +3. Titanium does do a +2, but it's, again, rare. Most of the time a +4, but it can do. Scandium doesn't, though. It's always a +3. So in this case, we have to make an assumption. By the way, it's actually a limitation on the worksheet here. So we've got nickel 2 oxide plus nitric acid. I'm going to form nickel 2 nitrate. So remember, we're forming, this is a metal oxide and acid. So we're going to form salt and water. Yeah, nickel nitrate plus H2O. I can't, it's word. So easy to do. Bad habits for a chemist. Yeah. Next, metal plus acid, salt and hydrogen. MASH. Metal plus acid, salt and hydrogen. So what's the salt? Magnesium sulfate. Going into symbol. Bad habit, Mr. Duncan. Magnesium sulfate. No Roman numeral needed because it's not a transition metal, so it's always +2 plus hydrogen gas. Next, this is, by the way, this is a great question now. This one, you need to make sure you know. This is one of the ones that Edexcel absolutely loves. Ammonia and hydrochloric acid. Now, can I just point out, I love this demo. It's such a wicked demonstration. I do this for you guys as often as I can, really. The reason being is this demonstration, of course, you'll probably remember. I'm just going to do the revision because, God, it's so common at GCSE. You guys will remember this. Yeah, I've done this with you guys so many times. Yeah. I'm just trying to seal the tube. There we go. So this here is cotton wool. Yeah, sometimes put as mineral wool, but I'll put cotton. Cotton wool. Now this one is soaked in concentrated conch ammonia solution. Conch ammonia. Ammonia sol, brackets AQ. It's always nice to do that. And this one is soaked in concentrated hydrochloric acid, which means what will happen is I'm actually going to get now. Can I just point out? Nice for me to remind you guys of acids, acid chemistry. Remember that if you have HCl and it is a gas, then that's going to be called hydrogen chloride. Be careful. It is not said to be an acid. Remember, acids cannot be acids unless they're in water, which means you must have the state symbol aqueous. So that's now hydrochloric acid. Yeah, you've got to be really careful. Hydrochloric acid is aqueous. Be careful. Now, the reason why you do this demo is because what comes off the cloth is HCl gas. Comes off the cloth. And off the ammonia does the same thing. You get ammonia gas. Yeah. Now, the great thing about this demo is it's a demonstration for diffusion. Comes from year 9 chemistry. Technically, I actually do this demonstration, folks, for year 7s, trying to get it, because it's so frequently asked by Edexcel. I desperately want to reinforce it over and over, putting it into kids' brains so it sticks. Because what you get is you get the formation of smoke. And you get a ring. I shouldn't do it like that. You get a really nice cloud. Yeah. You get a cloudy white ring of smoke right there, which is really interesting because it's not evenly distributed. Yeah. It's always closer to the HCl. Now, the reason for this demonstration, so whenever you put ammonia and HCl together, you get white smoke. Yeah, and that white smoke is ammonium chloride. And it's white smoke. And the reason why it's traveled and it's formed where it has is because the hydrogen chloride gas has a relative molecular mass, an RMM, RMM or MR, which is more common now. An RMM of 1 for hydrogen, and chlorine is 35.5, so the total is 36.5. And that's to 3 sig fig, Dave. Although at A level, you always give relative molecular masses to 1 decimal place, but at GCSE, you don't need to. Now, ammonia, on the other side, we've got nitrogen, of course, which is 14, and hydrogen, which is 1 times 3. So we have an MR of 17 at GCSE, at A level 17.0. And what that means is it's lighter. This one here has a smaller MR. So therefore, smaller MR, therefore diffuses more quickly. Therefore, gas particles move more quickly, move faster. Therefore, travel a greater distance, travel further in the same time. That's one of the ones, that's one of the marks that students always miss. You say they move faster, they've got a smaller MR, therefore travel further in the same amount of time. So the white smoke forms there, closer to the HCl than to the ammonia. It comes up so frequently. The reason why it's such a rare equation as well, by the way, folks, is because this is a nice reminder of the acid rules. If you do metal plus acid, you make salt and hydrogen. There's MASH. That's one of the words that one of my A-level kids came up with years ago. MASH. I thought it was a really great one, actually. They always did MASH. Just a reminder that was H2. And then you have a metal oxide. I'm going to zoom in. Then you get metal oxide or hydroxide, either one. Or hydroxide plus acid. And that gives you salt and water. Salt and water. And then you have a metal carbonate. So one thing you always notice with this metal carbonate plus acid is that you always create salt, always, but you get water and CO2 now. Water, and I'm just going to put CO2 because I'm running out of space. What you always realize here is you get a salt. You always get a salt from an acid-base reaction. We've got acids. Let's do the acid in red, of course, for pH, low pH on the pH scale. Yeah. And then we've got our bases, which I'll do as purple. Yeah. Just to tell you, by the way, I shouldn't really do that, although I can, because the metals, of course, are not alkalis. They're bases, but not alkalis. Remember, alkalis are soluble bases. But it's nice to see the two different universal indicator colors. So the question is now, I'm going to ask you this one. I'd like you to everyone post on the chat. So why is this special? Why is that special? Complete the equations, please, year 11. Why is that a complete equation, and why is it special? Because that reaction there, Edexcel adores. I don't really know why. Actually, I kind of do. It's because it's weird. It like breaks the rules. I get it. This is the thing with chemistry, is you do kind of get used to the idea of learning the exceptions. Oh, it's cute. How are you guys getting on with that? Complete the equation. Come on, Meryl. Help me out. What am I going to make? It's because we only get one product at the end. Yes, Tom! Nailed it. Thank you. Good job, year 11s. Really pleased. Yeah, we only get one product. Great job, Harry. There's no water. Yeah. Ammonium plus CO. No! Ouch! Come on. Smashed it. I love the fact that you put ammonium chloride. I prefer it. Yeah. I've just suddenly realized ammonium chloride. That's amazing. Yeah. What you get is ammonium chloride, and that's it. No water, no hydrogen. It's just that one product. Just to show you, by the way, that this equation, if number one is it's ionic. It's another weird one. That's ionic, folks. That's really weird. There's no metal. Oh my God, that's a weirdo. We've got an ionic compound with no metal. Whew, not good. Lots of people struggle with that. High melting point, ammonium chloride. Just to tell you, by the way, that reaction technically is actually reversible, but only under high temperatures, just to let you know. Ammonium chloride, if you heat it, it'll actually decompose to turn back into the others, which are back into HCl and ammonia, which is really interesting. But by the way, I'm going to give you another version of this, folks. Can everyone now do this one for me? And there's a reason why I'm choosing it. Can everyone now do that equation? Give me the answer to that one, please. And I'm really tired. Yeah, it's okay. Me too, dude. Me too. You're joking. I've had like 14 cups of coffee. Look at that. That's 14 cups of coffee right there, Anch. 1 million cups of coffee. How many times can I say coffee? In fact, we've done this before. How long would it take me to say coffee 14 times? Yeah, that's not very long. I reckon about 2 seconds. Yeah. I probably ought to stop drinking coffee, to be fair. I think it's probably not great for my health. Great job, Noel. Elijah's here. Elijah, I didn't even see you there. Rocking up. Merrill, are you saying that I shouldn't drink coffee? That is not healthy, Mr. Duncan. You probably die from coffee. No, coffee's my friend. I've also got Tom Harkin. I've got Elijah as well. Has anyone seen Audrey? Is Audrey here? I'm going to save that. There we go. Oh my God. Sorry, there you go. It is ammonium nitrate. Well done. Great job. By the way, there is a reason why I've actually done this one. Ammonium nitrate. This one here, folks, that compound is fertilizer. Yeah, fertilizer. That's the fertilizer song, by the way. I think it was by the Beatles. Think. Yeah. So that is fertilizer. Ammonia is used to make. Yeah, used to make, capitalize make. Used to make fertilizer. Yeah, used to make. Be careful. But ammonium nitrate is actually fertilizer. What are you saying? Sorry out there. Saying stop out there, Sian. Is it my singing? I don't see what they put. I love the Beatles. Do you not like the Beatles? Ammonia is used to make fertilizer. There you go. How about that? That was terrible. That was a mess. I kind of ruined it, didn't I? Oh, come on. Not the BTS. I don't know who BTS. BTS. How about that? BTS, there you go. I'm loving it. Anyway, going back to this. Did you say ooh? Thanks. Ugh. Anyway, back to this guy. Okay, so we've got ammonium chloride. There we go. And no other product. Very strange. Next one, metal hydroxide plus acid, salt, and water. Calcium hydroxide becomes calcium nitrate. Calcium nitrate. Calcium nitrate plus water. That's a French for water. Yeah. BTs. I don't know what BTs is. Do you mean Beatles? Yeah, Beatles. Yeah. What BTs? What's BTs? Oh, BTs is weird. Classify each of the following metals as having high, medium, or low reactivity. Well, that's quite nice. This is just the reactivity series. Yeah. So silver is low. We all know that. Magnesium is high. Yeah. Iron is medium. It's kind of in the middle. Zinc is medium, crazy high. It's high. Copper is low. Go. SMH, Mr. Duncan. What's that stand for? SMH. I've lost my marbles. I'm sorry, folks. Forgive me. Right. Shaking my head. Oh, big regrets. Yeah, so you should be. Yeah, Merrill. Okay, so we've got a question here looking at 4 different reactions. Yeah, and they're asking you to decide if it's proton or electron transfer. Therefore, redox and acid. So let's tie these together. Number 1, if it's proton transfer, then it's going to be an acid base. We agree with that, don't we? Because acid and bases is all about protons. It's all about H+. Yeah. So I'm going to do the rest of lesson in Yorkshire. Right, okay. So H+, we know that acids are proton donors. Proton, you gotta roll your R's. Well, I don't know what accent dropped into then. Don't know. Proton donor from an acid, and we've got bases. Proton acceptor base. Oh no, it's gonna. Oh no, base. Proton acceptor. Oh no, can't spell either. Acceptor. There we go. Proton acceptor, proton donor. So that's acid bases, and that's talking about H+. Redox, oh no, Yorkshire pudding. Tom, did you say no Yorkshire? I love Yorkshire puddings. Oh no, you just said you know Yorkshire, please. Oh, that's not what I read. Sorry about that. Next is electrons. You know, protons are H+. Protons. Electrons are E-, and that's redox. We know electrons are redox. There we go. Tie them together. Yeah. Good to do that. Right. So now we've got to decide which one's doing which. So, sorry. Try Welsh accent. Not very good at a Welsh, though. Mr. Duncan, RMB, your friends / co-workers, people may watch this. I know, and I'm very aware of this now, and I'm now regretting the terrible Yorkshire accent. Yeah, I know. So what's going on here? Number one, as soon as that, I can't turn it off now. It's a nightmare. So I've got. Would everyone agree? I've seen an acid. Look, there's an acid. So immediately I'm realizing this is proton transfer. Yeah. So that's an acid-base reaction. So protons, yeah. And it's going to be redox. Sorry, it's going to be acid-base. Lol, yeah. Now, the tricky part of this is that you're half tempted to realize. So if we look at this a bit more, you can make the argument, folks. You really could. Because if you actually notice, the protons technically aren't actually being transferred to anybody. The Cl is what's being transferred. But I don't really like the question. The question has a hole in it there. The answer is it's both. I don't really like it. You are neutralizing. That is an acid-base reaction. You are neutralizing an acid. But it's actually a redox as well. We got to tick both. Let's just look at why. The reason being is at the beginning of the reaction, we have calcium with no charge at all. This is calcium elemental metal. Now, what that means is it has no charge. So this is calcium 0. Yeah, calcium with no charge. Well, this is now hydrochloric acid. Now, hydrochloric acid is H plus and Cl minus. Agreed? Now, what's happened here is in calcium chloride, I've got Ca2 plus and Cl1 minus. All I'm doing is, guys, I'm taking the compounds and I'm disassembling them into their ions. So, and then I've got hydrogen at 0. What that now means is if we just make the ion disappear who's not doing anything, so that calcium is going from calcium 0 to calcium 2 plus. That's losing 2 electrons. That's losing 2 electrons. And what's happening is H plus is going to H2, which is H neutral. Well, that means it's gaining the electron. I'm going to put that as H2 there. And what I'm going to do is I'm going to this is very much higher level, folks. And in reality, the GCSE, they never push you this far. But you need to recognize that as an acid base. Yeah, that's an acid, and all metals are bases, except for the really unreactive ones like gold and platinum. Yeah. But you can disassemble this to be the ionic half equations. Calcium is going to form 2 plus and losing 2 electrons. The hydrogen is going from H plus and is forming H2. I can now balance for atoms, balance for charge. Now, you'll notice is these equations now go together. Yeah, to form the overall, the Cl is just a spectator ion. It's not actually doing anything. So that's actually both, which is really stupid in terms of the question, because it's adding a level of difficulty there, which is never done at GCSE. The next one, by the way, no acid here. This is redox all the way. Yeah, let's look at why. Because here's a question for you, year 11. What is the charge on iron in that compound? It's somebody you have to know, by the way. I'm also going to give it its color. Yeah. There we go. Iron oxide. But the question is, which one? What's the charge on the iron? Just give you a second to have a go at it. You can pause the video if you like. That's Fe3 plus, which is brown. It's rust. That you have to know that as rust. This is iron 3 oxide, Roman numeral 3 oxide. Got to know that one, folks. Iron 3 oxide. And we're adding carbon. Now, carbon has iron 3 plus O2 minus. That's absolutely spot on, Ira. Well done, Meryl. Plus 3. Yeah. Well done, Ira. Yeah. Iron 3 plus. So carbon has no electrical charge, but it's now forming carbon monoxide. What's the charge on carbon in carbon monoxide? Oh, that's much more interesting. Oxygen is always 2 minus. If we disassemble that, Yeah, I've got O2 minus, and there's only one of them. So therefore, carbon must be in a +2 to compensate. Cancel it out. Well done, Tom. Great job. So, guys, this is redox all the way. Yeah, the iron is also dropping to 0. It's starting off, if I just put the numbers, God, this is, can I just point out, this is really hard, this, folks. This is proper level 9 stuff. Yeah, okay, maybe not level 9, but it's certainly, I mean, this is A level. This is grade CD A level. Yeah, this is hard. These are love 8s. Yeah, this is a love 8. I keep wanting to write love. Ah! Oh no, oh no. Love 8. So this is +3 minus 2, 0, 0, +2 minus 2. Oxygen hasn't changed. Oxygen is a spectator. Oxygen's not doing anything. Yeah, but the carbon is going from 0 to +2. It's losing 2 electrons, and the iron is going from +3 to 0. It's gained 3 electrons. Yeah, so that there is electrons and redox. Hard that. Next. Oh, that's clever. Right, true acid base, no redox. Yeah, so this one, acid base, because we've got an acid. As soon as you see an acid, sulfuric, got to know it, of course. Yeah, then you immediately, it's protons and acid base. Yeah, this is generally not redox though, because if you notice, +2 magnesium, -2 oxygen, +1 hydrogen, +6 sulfur, -2 oxygen, +2 magnesium, +6 sulfur, -2 oxygen, +1, -2. Nothing's changed. Yeah, oxidation states are all the same, so that's just acid base. Next one, redox only, no acid here. We've gone from a 0 oxidation state for zinc, a +2 there. Yeah, we can ignore the sulfate, because the sulfates remained unchanged. I'm tempted to do. But anyway, I'm just going to skip that 0 and then +2. So the zinc's gone from a 0 to a +2. Zinc's gone from there to zinc 2+, and it's lost 2 electrons. Remember, when you're doing half equations, electrons always go on the most positive side. Yeah, it's actually a really handy thing to know. Opposites attract, so they go together on the same side. Yeah, copper, of course, copper's doing the opposite. It's going from copper 2+ in copper sulfate and going to form copper metal. So it's gaining 2 electrons on that side. Yeah, nice to do the half equations. As I said, proper higher level GCSE. I'm really pushing you there, folks. These questions, if you're able to do these, that's redox, of course. Very interesting. Interesting question. Right. Okay, folks. Continuing the idea of electrolysis, we've been doing a bit of redox up there, and they've then walked the redox into electrolysis, which is nice. So remember the difference between molten and aqueous. Yeah. So just to do a little bit of an explanation for the molten and aqueous bit. I'm nearly at the end of the question, by the end of the paper. So I'm just going to add a bit here. So in electrolysis, yeah, we've got 2 scenarios. Molten, which means molten it's liquid, it's hot. The word molten literally means hot liquid. So if I take, which one did they give you? Potassium what? Potassium bromide. So they've given you KBr and it's molten. What does that look like? I've got a container, I've put in KBr, so the only ions I've got there are those, because it's molten, which means there's no water, and I've made it liquid. This is hot. Yeah, this is going to be potassium bromide. Melting point is going to be about 650. It's high. So if I now electrolyze this, stick in my electrodes, yeah, let's make that one the positive, that one the negative. So the positive, that one's going to go there, that one's going to go over there. Yeah. So then they're going to ask us for the products. They just want the products. That's nice. There we go. So products at the positive electrode. So the only ions I've got are him and him. Yeah. At the positive electrode, it's going to attract the net. Let's color code it, color coordinate it. Opposite charges attract. So I'm going to get bromine. Let's actually do the half equation. Why not? Let's go a bit. Oh no, the half equations are down there, but let's do it anyway. No, okay. Yeah, let's just. By the way, do you notice it doesn't say name or formula, which means if they just say identify in your exam, you just identify it with either a name or formula. But if they say name, you've got to give a name. If they say formula, you've got to give a formula. But in this case, I'm going to get bromine. I'm going to give the name because it's more commonly mistaken because people give bromide, but it's not. The bromide becomes bromine. At the negative electrode, I'm going to get potassium metal. Next, copper sulfate aqueous. What does this look like as a picture? Oh, I'm going to draw it here. So I've got Cu2 plus, SO4 2 minus, and H plus, and OH minus. Those are all the ions I've got in that beaker. The reason being, students go, where did the H plus and OH minus come from? It came from the water, folks. Yeah, aqueous means in water. And we know that water breaks apart to give us H plus and OH minus. What that now means is what's going to happen. I'm actually going to make that bigger. I was trying to fit it onto the question, but realized there really is very little value in that. So let's do this. So this is aqueous, CuSO4 aqueous. Oh, it's being a bit slow now. So I've got Cu2 plus from the copper sulfate, SO4 2 minus from the sulfate. Yeah, but then I also have water, which doesn't do anything because it's neutral, but that splits apart to give me H plus and OH minus. Right, I now put in my electrodes. Let's put in my electrodes. Oh, let's put in my electrodes. Right, who's going to go where? Yeah, so this is the positive electrode. This is the negative. Right, all the positives are going to go over there. The question is, who's going to get made? And this is where I need the reactivity series. And copper is below hydrogen. It's less reactive. So at the negative electrode, I'm going to get copper. I'm not going to get hydrogen. I'm going to get copper metal. It's going to turn orange. Yeah, I'm not going to get hydrogen because copper is below hydrogen in the reactivity series. What am I going to get at the positive one? So this one is either SO4 2 minus or OH minus. In reality, the sulfate never does it. It's always the OH minus, and I'm going to get oxygen. You've just got to know that one, folks. Again, GCSE, EdXL, common. Right, next one. Sodium iodide, aqueous, which means I have Na plus, I minus, H plus, OH minus from the water, all in the same beaker. Right. I add my electrodes. Who goes where? So at the positive electrode, I'm going to get OH minus and I minus. Now, the one thing you've got to remember is that if you've got a group 7 anywhere, you're going to make the group 7. So in this case, I'm going to get iodine. Yeah, that one's going to go. That one's not going to do it. Yeah. Next, what have I also got? I've got sodium plus and H plus. Which one's less reactive? Sodium is way high in the reactivity series. I'm now going to get hydrogen gas. Hard. It's clever, though. You do get used to this, folks. You really do. The more you practice it, the better you get. Right. Last bit, half equations. 2 rules, 2 steps. Yeah, 2 steps. Step 1, balance for atoms first. Balance for atoms. Step 2, balance for charge. I've suddenly realized I'm going to overshoot my lesson. Balance for charge. Right, we've got 1 copper, 1 copper. Oh, that's easy. I've just balanced for the electrons. So that becomes Cu2 plus 2 electrons. They go onto the side. Remember, you can only ever add electrons. Yeah, and they're going to be attracted to the more positive side. So they're going to go on that side. Yeah, next one. Oh, this one's really clever because they repel. Remember, electrons, first step, balance for atoms. Yeah, so I've got 2 chlorines out, 1 chlorine in, balance for atoms. Followed by charge. Well, I've got a balance for electrons. They're going to be repelled by that guy, which means they're going to go onto this side, and I'm going to need 2 of them to balance the charge. Next, O2 minus. Again, they're going to be repelled by the 2 minus. So O2 minus going to O2. Balance for atoms, balance for charge. Lots of people will put on 2 there, by the way, folks. But remember, it's 2 times that is -4, so we need 4 electrons. That's a level 7-8. Love 7-8. Common one people make mistakes on. Hydrogen gas. H plus going to H2. Balance for atoms. Balance for charge. They'll be attracted to that side. So we'll go over there. And we're done. Right, guys, I will post on the classroom. That brings us to the end of the lesson. There we go. There we go. Hey, folks. Right. I'm sorry that I've overshot a little bit. I'll be quick and ending. Guys, have a great rest of your day. It's been lovely to see you guys, as always. Take care of yourselves. And give me an email anytime if you want me to go over a topic. Yeah, I'd really like to receive some of those messages. So, guys, have a great rest of your day. See you soon, guys.